Last week we started talking about the basic data types in Python, right? We talked about some of the basic groups of types. Okay, now we are going to continue talking about built-in types, but we specifically going to talk about the connection types. So you see here, these are the types in which we can store connections of related elements. Okay, now sometimes they called iterable. We're going to talk about what does iterable mean and how we can use it later. But for this week, we're going to talk about these types. We start with the sequence types, and then we can add to them. So the sequence, before we start with the sequence type, we need to understand the difference between two types of objects. There is a mutable object, and there is the mutable object. So mutable means updatable. Immutable means unupdatable. The object itself is not updated. What does that mean? When we create an object and use a reference to refer to that object, there are 3 steps that are happening. So when we say x equal, so let's say A, B, C. Okay, there are 3 steps that are happening here. The first step is that the object itself is created in some place in the memory, and the value stored in that place in the memory is called A, B, C. This is the value there. The memory location has a reference. So let's say this is reference 1, 2, 3. Okay, so that's the first step, creating the object in one place in the memory. The second step, in another place in the memory, you create a place for the variable that is the reference variable. Okay, so that's the second step. Okay, the third step is the assignment. So what happened in this assignment? We copy the address of the object and store it in the reference variable. So now we have a reference that points to that object. Okay, so that's what happens with any object. If the object is mutable object or updatable object, it means that when we use the reference to change the value stored in the object, we would go directly to the object and change it. So let's say we want to say x plus equal x. 1, 2, 3. So I'm appending a string to the already existing string. So I'm trying to use the reference to change the value stored in the object. If the object was mutable, then we would go to that memory location and just change the value. Okay? But that does not happen because strings are immutable. Okay? Now, if it was mutable, we would have something like this. If it wasn't, because it's not mutable, we cannot change the value in the object itself. The value in the object itself is unchangeable, immutable. So what happens when we do a statement like this? This is a valid statement, right? So what happens when we execute a statement like this? We are using that reference to make change in the object, right? So what happens is that we create another object in the memory. That other object has another memory location, let's say 4, 5, 6. And that other memory location would have the new value. So here we wanted to have to keep the old value and then append 1, 2, 3 to it. Okay? So that's the object creation part. And then the reference, the memory location of the new object will be stored in that reference variable that we use. So that reference variable would be pointing to the new object, and the old object will be just discarded, and the garbage collector will be collecting it later. Okay? So mutable object, when you try to change a mutable object through a reference, the reference itself doesn't change. It goes to the actual object and change the value stored there. But when we try to use a reference to change an immutable object, a new object would be created, and the reference of that new object will be stored in the reference that we have been using to make the object. Okay? So that applies on any type of object, including the sequences that we are going to learn about today. So when we start talking about the different types of sequences, some of them are mutable, some of them are immutable. So you know what does that mean now. Okay, so the types of sequences that we have, these are the main types. List, tuples, string is a special type of sequences. We started talking about it. And then there are ranges, also a special type of sequences. Now there is another special type of sequences that you might need to know about. That is, so these are contain general types, and these general operations apply on them. Now there's another type of sequences that goes to the binary level. So it's a more low level type of sequence, and it allows and or at the binary level. So it's a lower level. So you might need to know that since you might be reading data from machines and stuff like that. So if that's the case that happens, you know that there's another type of sequences that goes down to the binary level. Okay? But in this course, we're just gonna talk about the generic cases. So we talk about the generic types or the generic, but we keep in mind that there's that binary level of work that is available in that. Okay. Ranges is a special type of sequences as well. We're gonna talk about it not this hour. We're gonna talk about it in the next session. So all these operations, so these are the operations common among all the sequences, almost all of them. You like the concatenation and repetition does not work with the range, and we will see why. But other than that, all of them work on all list, the tuples and the strings. Okay, so we've seen the concatenation how it works on the strings, right? It works the same way on other sequences. Just create a copy plus concatenate, so append the multiply or the star creates a copy of the sequence and then concatenate it what the number of times according to the given number. Okay, so we've seen that with the strings before. We can access the element in the sequence using the index, and this index is a zero-based index. Okay, so that applies on the strings and on any other sequences. So that should be familiar, but except that the fact that we can have negative values there. So the index itself starts at 0, right? And any positive value would be the corresponding index. If we try a negative index, it will be replaced by length plus I. So the I itself is negative, right? So we'd say length, it would be, if I say -1 as I, it would be replaced by the length -1. So that would be the last index. If I enter the -2 as the index, it would be replaced by the length -2. So that's the second element from the back. All right, and so on. Now, these ranges are very similar. If you worked with MATLAB, you would be familiar with that, with these. Okay, so these ranges, so we can have a slide of the we can have a slice of the sequence starting by I and ending right before J. So J is also now included, just like normal. Okay. We can also change the step. So by default, the step is 1. Right? If we want to have every other element, we will change the step. Okay. Now, there is something I wanted to highlight here. When we are describing a syntax, this might be a little bit confusing because the square brackets can be part of the original syntax, but not in this line. So when you are reading documentation and you're reading something that describes the syntax, sometimes the square brackets, when it's not originally to the sentence, it just indicates an optional value or optional code or optional argument. Okay, so what we're seeing here is that x itself is the mandatory. So when we say s.index and then we send it x would be the element that we're looking for. So this is a function which returns the index of that element, the element stored in x, right? So we can send one argument because the 2 other arguments are optional. So we can send one argument, and so it will start looking at the sequence from the beginning and to end. If we give it 2 arguments, then the second optional argument here would be the starting index, right? So we can ask it to start looking for the element at a particular index until the end. So we give it last index, it's going until the end, yes.
So the difference changes in x.
So equal sign is equality, right? So it has to be that next in. And looks whether the x is part of the next. We can try that.
Oh.
So S is a sequence of elements. We try to see whether x1 is one of them. Okay, so here we have 2 levels of optionality here. So you see there's one square bracket starts with this comma, right? And then another square bracket at the end. And then inside of it there is another square bracket. So there are two types of optionality here, or 2 levels. So we can send it 1 argument, or 2 arguments, or 3 arguments. Okay? So don't confuse it with the original, with the square bracket that is the original sentence. All right. Okay, so let's start with the list. Okay, so the list, I don't know if you know Jonathan. So the list is indicated by square brackets. So it's just a column of values surrounded by square brackets. Okay. Now, the elements of the list could be of any kind. But the general case that it is used with G stuff. And that's the other thing I wanted to highlight here when you look at the operation. You can see here there is minimum, maximum. So in order to figure out what's the minimum, what's maximum, there has to be some comparison, right? Now, in order to compare, you have to compare comparable times. So, yes.
So what would happen?
They will give you an error. I'll give you an error. Okay, so here, so I have a list here that has different types, as you can see. So it is allowed, yes.
First index is 0.
Yeah, 0. First index is 0. So when we try to access the elements, we have to make sure that we don't try to access outside the index range, and we can just access the elements by the index. So all this should be familiar. Now here I have the element and index 3 is another list. So it looks like I'm having a 2-dimensional list, right? So but what happened is that what returns from, so this is my list, and then index 3 that returns the list, and then we sending the index operation to that return. Okay.